Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Hearty welcome to this special functions model question paper. I am going to discuss now. So now we are having the very first question is evaluate integral 0 to 2 x square dx by square root of 2 minus x. So quite obvious, it is clear that it is from it is like integral a to b. So we are going to change the integral from 0 to 1. In order to change that, we are going to use the transformation, put x is equal to 2t, then dx becomes 2 dt. When x varies from 0 to 2, t varies from 0 to 1. Therefore, the integral 0 to 2 x square by square root of 2 minus x dx becomes integral 0 to 1 4t square divided by square root of 2 minus 2t into 2 dt. So 4 into 2 divided by root 2, if we take common, then it becomes 4 root 2, and integral varies from 0 to 1, t square into the denominator becomes 1 minus t whole to the power of minus half dt. Now we are going to bring it in the standard form of a beta m comma n. Now this t square can be written as t to the power of 3 minus 1. Similarly, this 1 minus t whole to the power of minus half can be written as 1 minus t whole to the power of half minus 1 dt. Now it is in the standard formula integral 0 to 1 t power m minus 1 into 1 minus t whole power n minus 1, that is nothing but beta m comma n. Now this becomes 4 root 2 into beta of 3 comma 1 by 2. Now what is beta of m comma n? Gamma m into gamma n divided by gamma m plus n. So that becomes 4 root 2 into gamma 3 into gamma of half divided by gamma of 3 plus half, that is gamma 7 by 2. So 4 root 2 into what is gamma 3? Gamma n is given by n minus 1 factorial, so it becomes 2 factorial, and gamma half is nothing but root pi, and then divided by gamma of 7 by 2. So 4 into 2, 8 root 2 into root pi divided by gamma 7 by 2. So we are going to put it in the standard form gamma of n plus 1. So 7 by 2 can be written as 5 by 2 plus 1, and gamma n plus 1 becomes n into gamma n. So 5 by 2 into gamma of 7 by 2, 5 by 2 into gamma of 5 by 2. Once again, gamma 5 by 2 can be written as gamma of 3 by 2 plus 1. So once again that becomes 5 by 2 into 3 by 2 into gamma of that becomes 3 by 2 into 1 by 2 into root pi. So that becomes now 8 into 8, that is 64 root 2 into root pi divided by root pi gets cancelled here, gamma of half is root pi. So 64 root 2 divided by 15. Next, show that gamma of half plus x into gamma of half minus x is equal to pi by cos pi x. Now consider the left hand side, gamma of half plus x into gamma of half minus x. That can be written as gamma of half minus x into gamma of half plus x. Half plus x can be rewritten as 1 minus of 1 by 2 minus x. So it is of the form gamma n into gamma of 1 minus n. And we are having a standard formula, gamma n into gamma of 1 minus n is given by pi by sin n pi. So this is nothing but, now here n is nothing but 1 by 2 minus x. So that is pi by sin half minus x into pi, that is nothing but gamma, so pi by sin pi by 2 minus pi x, sin 90 minus theta, sin 90 minus theta is nothing but cos theta, so pi by cos pi x. Okay, right. Next, third one. If the power series summation an into x power n is such that an is not equal to 0 for all n, and limit as n tends to infinity, mod an plus 2, an plus 1 by an is equal to 1 by r, Then prove that summation an into x power n is convergent for mod x less than r and divergent for mod x greater than r. Given that the summation an into x power n, n x power n, let un and summation an into x power, let un and un is equal to an into x power m. We are going to consider the power series, and here un plus 1, n plus 1th term will be an plus 1 into x to the power of n plus 1. Now we are going to consider the D'Alembert's ratio test, and we know in the real analysis we have learned about the convergence and divergence of the series. So limit as n tends to infinity, un plus 1 by un is equal to limit as n tends to infinity, an plus 1 into x to the power of n plus 1 by an into x power n. So that becomes limit as n tends to infinity, an plus 1 by an into x. That is nothing but mod x into limit as n tends to infinity mod an plus 1 by an. That is equal to, and here it is given in the hypothesis, that is modulus of an plus 1 by an is equal to 1 by r. So this is nothing but mod x by r. By D'Alembert's ratio test, we learn that the series is convergent if limit as n tends to infinity mod un plus 1 by un is less than 1, and is divergent if it is greater than 1. So limit as n tends to infinity un plus 1 by un less than 1 implies mod x by r is less than 1. That implies mod x is less than capital R. That implies summation an into x power n is convergent. And this is going to be divergent if limit mod un plus 1 by un is greater than 1. That means mod x by capital R is greater than 1. That means mod x greater than r. Thus, the given series is convergent if mod x is less than r and divergent if mod x greater than r. I hope this is clear. Now fourth one. Prove that hn double dash x is equal to 4n into n minus 1 into hn minus 1 of x. We know that the recurrence formula, first recurrence formula of Hermite polynomial, hn dash of x, that is first derivative of nth ordered Hermite polynomial, is given by 2n times hn minus 1 of x. So differentiating with respect to x, we get hn double dash x is equal to 2n is a constant, comes out. Hn minus 1 of x derivative is nothing but h dash hn minus 1 dash x. Now once again applying the recurrence formula for the first recurrence formula of Hermite polynomial, that is given by 2 into the number order, 2 into n minus 1 into hn minus 1 minus 1, that means hn minus 2 of x. That is nothing but 4n into n minus 1 into hn minus 2 of x. Thus hn double dash of x is equal to 4n into n minus 1 into hn minus 2 of x. Now prove that h2n at 0 equal to minus 1 whole power n into 2n factorial by n factorial. Now we have from the generating function that e power 2tx minus t square equal to summation t power n by n factor into hn of x. Putting x is equal to 0 in this, we have summation t power n by n factor into hn of x, that is nothing but e power hn of x is equal to, that is hn at 0 equal to e power 0 minus t square, that is e power minus t square. Now expanding e power minus t square, we have 1 minus variable plus variable square by 2 factorial minus variable whole cube by 3 factor and so on, minus 1 whole power n into variable power n by n factorial. That is nothing but, here the variable is t square. So 1 minus t square plus t square whole square by 2 factorial plus so on, minus 1 whole power n into t square whole power n divided by n factorial. Now equating the coefficients of t power 2 to 2n on both sides, we have 1 by, on the left hand side we are having 1 by 2n factorial h2n at 0. h2n at 0 is nothing but minus 1 power n divided into 1 by n factorial. So we are having that is, we are comparing t power 2tn. So 1 by 2n factor into h2n at 0. That is nothing but minus 1 whole power n divided into 1 by n factorial. So we are having h2n at 0 is nothing but minus 1 whole power n into 2n factorial by n factorial. Again, equating the coefficients of t power 2n plus 1 on both sides, we observe that the right hand side, the terms are having only the even powers. We are having t square, t power 4, t power 6 and so on. So this is nothing but, so 1 by 2n plus 1 factor into h2n plus 1 at 0 is nothing but 0, because there are no odd powers of t. Thus we prove the that is h2n at 0 equal to, it is only minus 1 power n into 2n factorial by n factorial, and h2n plus 1 at 0 equal to 0. Okay, I hope this is clear. Now, Legendre polynomials. Problem number 6. Prove that Pn of minus x is equal to minus 1 whole power n into Pn of x. The generating function of the Legendre polynomial is nothing but 1 minus 2x z plus z square whole to the power of 1 by 2. That is nothing but summation z power n into Pn of x. 1 minus 2x z plus z square whole to the power of half equal to summation z power n into Pn of x. Call that as equation number 1. Now replacing x by minus x in 1, we get 1 plus 2xz plus z square whole to the power of half equal to summation z power into Pn of minus x. Call that as equation number 2. Replacing z with minus z in the generating function, we get 1 plus 2xz plus z square whole to the power of half. That is equal to summation minus z power n into Pn of x. So that is nothing but summation minus 1 whole power n into z power n into Pn of x. Now comparing 2 and 3, the left hand side of 2 and 3 both are same. That means we are having summation z power n into Pn of minus x is same as summation minus 1 power n into z power n into Pn of x. That implies Pn at minus 1 equal to minus 1 power n into Pn of x. Okay, so we got the required answer. Now prove that Pn dash equal to 1 by 2 times n into n plus 1. Now once again consider the Legendre differential equation. What is the Legendre differential equation? 1 minus x square into d square y by dx square minus 2x into dy by dx plus n into n plus 1 into y equal to 0. So we are having Legendre differential equation 1 minus. Now in this, let y is equal to Pn of x be the solution. Okay. So because it is a solution, it should satisfy the given differential equation. That means 1 minus x square into Pn double dash x minus 2x into Pn dash x plus n into n plus 1 into Pn of x equal to 0. Put n is equal to 1 in this. That means when n is equal to 1, x is equal to 1. Sorry. When you put x is equal to 1, the first term vanishes. So we get minus 2 into 1, that is minus 2 Pn dash at 1 plus n into n plus 1 into Pn at 1 equal to 0. In other words, Pn dash at 1 equal to, take it to the other side. So we get 1 by 2 into n plus 1 into Pn at 1. So we know that Pn at 1 is equal to 1. So we have Pn dash at 1 equal to 1 by 2 into n plus 1. That's it. Next question number 8. Prove that j minus n of x is equal to minus 1 power n into jn of x, where n is a positive integer. We have the Bessel function jnx is given by summation minus 1 power r divided by r factor into n plus r factor into x by 2 whole to the power of n plus 2. Now replacing n by minus n, we are having j minus n of x is equal to summation minus 1 power r divided by r factor into minus n plus r factor into x by 2 into minus n plus 2r. Now here we should have the denominator factorial. What is there? R factor, anyway r is positive. Further we should have minus n plus r must be positive. That means r minus n must be greater than or equal to 0. In other words, r must be greater than or equal to m. So we are going to replace r minus n by s. Therefore, r becomes n plus s. So the value of r varies from n to infinity. So j minus n of x can be written as summation r running from n to infinity minus 1 power r divided by r factorial into minus n plus r factorial into x by 2 whole to the power of minus n plus 2r. That is nothing but summation minus 1 to the power of n plus s divided by n plus s factorial into s factorial into x minus x by 2 into minus n plus 2n plus 2s. That is summation s varies from now 0 to infinity minus 1 power n plus s divided by s factorial into n plus s factorial into x by 2 whole to the power of n plus 2s. Taking minus 1 outside, minus 1 power n into summation minus 1 power s divided by s factorial into n plus s factorial into x by 2 whole to the power of n plus 2s. Therefore, j minus n of x is equal to minus 1 power n into jn of x. Thank you for watching this video.